For years, scientists have been developing systems to allow people who can't speak to communicate with their minds. These brain-computer interfaces attempt to translate patterns of brain activity into words and sentences. Back in 2021, this was the state of the art, a setup that allowed this participant to talk at a rate of 15 words per minute with a vocabulary of 50 words. 2 years later, a pair of teams have made rapid progress. The new studies show off systems that enable their two participants to speak at over 60 words per minute, with comparatively fewer errors and larger vocabularies than ever before. This research could be the groundwork needed to take brain-computer interfaces like these out of the lab and start developing practical and potentially life-changing technology. This is Pat. She has ALS, or amyotrophic lateral sclerosis, which impairs her speech and facial movements. And she's been working with a team of neuroscientists based at Stanford University to help develop their brain-computer interface. When Pat tries to speak, the neurons in her speech-motor cortex activate. This is the part of the brain that controls the muscles we use to speak. A series of microelectrode arrays inserted into Pat's brain can read the activity of over 100 individual neurons. These readouts then go into a machine learning algorithm. During training sessions, Pat tries to read out specific phrases. And the algorithm learns to match the sounds she's reading with the patterns of neuronal activity. This data is then fed into a language model with a vocabulary of over 100,000 words, which figures out what words those sounds are most likely to represent.
How do you like my music?
After training, Pat could communicate at around 62 words per minute, much faster than previous setups, and with a much larger vocabulary and fewer mistakes.
Hello, how are you?
The researchers say that using more electrodes, reading activity from more individual neurons, could make their system more accurate and provide even more information about how different parts of the brain actually work. Meanwhile, a second team from the University of California, San Francisco are tackling this challenge with a slightly different approach. Their system reads brain activity from the surface of the brain, and again can use a combination of a machine learning algorithm and a language model to decode that brain activity successfully into text, with a vocabulary of around 1,000 words or so, and a rate of up to 78 words per minute. But as well as producing text, this system can produce the sounds of speech, spoken by this moving avatar.
Do not be afraid to ask me questions.
The avatar isn't just reading out the decoded text. Instead, another algorithm has been trained to translate brain activity directly into sounds.
Great to see you again.
The idea is that this speech isn't limited to certain words and could potentially allow someone to vary the tone and speed of their speech in a much more natural way.
As soon as possible.
The team also experimented with making the avatar face respond to motor signals to produce certain expressions. Combining all these elements together could one day give people who can't speak the ability to communicate with much more nuance than is possible with text alone.
What do you think of my artificial voice?
Despite these advances, the two systems still have about a 25% error rate, and they speak at around half the average speed for English speech. As well as that, each of these systems has so far only been tested with one person, and we still don't know exactly what the safest and most accurate way of getting the most relevant brain signals might be. Still, this leap forward in the speed, accuracy, and vocabulary could be enough to show that a mass-produced product is feasible. It could be enough to start developing safe and practical hardware that's long-lasting and easy for people to use in their everyday lives. The next question is what the people who need it actually want from these kinds of systems, and how best to turn scientific progress on brain-computer interfaces like these into usable technology that can improve the lives of people around the world.
That's great. Thank you, Pat.